Okay. Before that, I would like to know how many of you are new to microservices? Let us have an interactive session. Please share it in the chat window.
Actually, I am aware of Spring and Spring Boot, but a little bit of idea in microservices.
Okay, okay, great. Okay. What about others? Please do share your details, like whether you have worked in microservices or you are new to microservices. If you have worked in Spring Boot, yeah. Okay. So guys, now today in today's session, we will get started with microservices. So the idea over here is, okay. The idea over here is I will give you a proper structured learning path and guideline about what you have to learn in microservices. What are the components that you need to know to become a microservices developer? If you are working in Spring Boot, then this will be a really good start to understand all the concepts. To understand what exactly you need to learn in microservices. Okay, fine. So today, let me just tell you how I will take the session. This is for 1.5 hours, that is till 9:30. So initially, let us get an understanding about microservices. Then we will go in for a simple hands-on. If you guys are sitting in front of the system, and if you're having your Spring tool suite ready, you can try this out with me. We will try creating a simple microservice and register it to Eureka Server. Okay. Your mics, please. Now let me share my screen. So first, let me give an introduction about myself. I hope you all can see my screen. Let me give an introduction about myself. I am Sripriya here. I am a corporate trainer for nearly 20 years of experience in training freshers and laterals in different corporates. My expertise is in Java full stack. I've been doing trainings in Chennai, Bangalore, and Hyderabad. I have trained thousands of professionals like you transition into IT careers. Okay, so these are few corporates where I have done training, and few places I have done exclusive microservices training, especially in Society General, Harman, Publicis Sapient, and also State Street, which is in Bangalore. So these are all companies relevant to financial background. Of course, you might be knowing about Harman, the Bluetooth and the headphone stuff. So they are dealing with that. So there also I have done microservices training for experienced guys. This is about me. Now, let us see what are the topics that we are going to see now. Yeah. Thank you so much. Now, let us get started. Okay. I don't want to go through the slide. First, it will be monotonous. First, let me explain everything through the pictorial representation. Then we will go back to the slide just to review whatever we have seen is correct or not. In today's session, first, we will get an introduction to microservices. Then we will understand what are the key concepts of microservices. Then the third part is what are the advantages of using microservices. Then what are the key components? This is very important. Where usually when we want to start learning any technology, there is always a problem. The thing is, we really don't know where to start, what are the topics that we need to learn. So that will be very clear if you are understanding what are the key components of microservices. If you know what are the topics that you need to learn in microservices, then it will be a complete full-fledged learning. So I will explain what are the components that you need to learn in case of microservices. Okay. Then we will go in for building a microservice. Guys, if you are from a Spring background or a Spring Boot background, it is very simple and easy creating a microservice. I'm not going to connect the microservice with the database as of now because we don't have that much of time. If you want, actually, like in my trainings, we usually do. So based on the timings we will create a microservice. Then we will register our microservice to service registry. So what is service registry? Everything we will learn now. Okay. I hope this is clear. Let us get started. First is, let us get an introduction to microservices. What are microservices? Microservice is an architectural style that helps to decompose one big application into a suite of smaller services. Say, for example, if there is an e-commerce application, in case of an e-commerce application, I need to work with multiple modules. That is, we will be creating modules for product, for user, for seller, then for cart, then for wish list, for order, any application of that matter. This is one single application where I have multiple modules. Say, for example, if I'm taking a delivery app, in that case also I will have the same thing. Order, seller, user, restaurant. If it is a delivery app, I'm having restaurant. If it is a booking app, like booking an appointment with the doctor or booking a ticket for a movie, then booking will be a module. Then movie will be a module. User, as usual, in every application, user will be a module. There will be something who will be providing the service, that will be a module. So usually in any application, in case of a monolithic application, the whole application has multiple modules. All these are modules in one single application. Once you have created it, what you do is you deploy this application into one single EAR, enterprise application, enterprise RQ file. This is a monolithic application. Okay, it is something like if I am conducting an event for my company, what I am doing is as I am just collaborating with everyone, everybody has to report to me only. I am the single point of contact. Finally, I collate everything for them, and then finally it is getting executed. This is a monolithic architecture where one single application is deployed in as one single EAR. What is a microservice? Microservice is an architectural style where one single e-commerce, any application of that matter, application is decomposed into suite of smaller services. What is the meaning of it? Now here also we are having same modules. Now rather than making product as a module of one single application, I will create it as a service, a microservice. It is an independent application which will be developed, deployed, and deployed independently, meaning to say that this will run separately. I am having seller. Seller will run separately. I have order. Order will be developed and deployed separately. Then how do they interact between each other? There are few mechanisms through which they can interact. Now, let me explain it with the same example. I am conducting an event. Now, what I am doing is I am delegating the work to different people. Okay, if you this group has to take care of the guest, this group has to take care of the accommodation, this group has to take care of the travel, this group has to take care of the food and catering. So now I am delivering, or I am just decomposing my single work into multiple people. Okay, how do they communicate? Suppose say one group is saying that the guests have arrived. Where should I make them stay? So they communicate through different mechanism, through phone or through WhatsApp, through email, like that. So similarly, here also, these microservices communicate through different mechanisms. One thing you need to remember, in case of microservices, each microservice is independent, self-contained, and it is deployed independently. Now, suppose say my microservice depends on a database. Suppose I'm working with product means I need to store the products in the database. So what should I do? Each microservice will have its own database. Here for the whole application, I may have one or two or three databases. Okay, but every module may be using the same database or different databases, but they are a part of the application. But here, each microservice can have its own database, or they can share the database. For example, I have wish list and history. These are two separate microservices. Wish list are reviews. I have only one single table. Why do I need to have a separate database? I can make them share these database, the same database. Okay, who coined this microservices? This guy, Martin Fowler, he only coined the term microservices. Netflix had an issue of video streaming. When they want to do the video streaming, they had a bigger issue of thing goes wrong in a monolithic application, the whole application crashes. Again, you need to debug and rerun the application. Here, it is not the scenario. We will discuss about the advantage later on. Now, I hope you can understand. In case of a microservice, it is one single application decomposed into a suite of multiple services. Each service is independent. Each service will have its own database. Each service can be developed and deployed separately. I hope it is clear. Now let me go back to the slide. Okay. Whatever I have told there, that is only here. It is an architectural style where one application is deployed as a collection of loosely coupled services. What is the meaning of loosely coupled services? It means they are not dependent on each other. As I told you, they are independent, they are self-contained. Whenever they want to communicate, there are few mechanisms. They are just like REST APIs. They can communicate using REST or RPC, remote procedure call, or they can communicate using message queues. One simple example of message queue I'll tell you. Suppose say you are going to a e-commerce application. You are adding the items and you are placing order. Immediately you get an email saying that your order is placed successfully. So in those scenarios, we can work with message brokers, messaging services. Okay. Here you can see it is a suite of smaller services, each running in its own process, communicating with lightweight mechanisms. How do they communicate? Either using REST or RPC or message-based API, which can be Kafka, RabbitMQ. It can be anything. Microservices, what they do, they help to break complex application into a suite of smaller services. Okay. What are the advantages of microservices over monolithic application? In case of a monolithic application, it is tightly coupled. Here it is loosely coupled services. The name itself says every application is independent. They don't depend on the other application. Here it is not the case. One module depends on another module. So they are tightly coupled. Now, if one error, one exception, one fault occurs in the application, you need to deploy the application again. Okay, here in this case, if a problem occurs in an application, it is independent service. So the problem may be in product service, or it can be in user service, or it can be in any other service. You don't have to deploy any other thing. Where the fault is, only that particular service you need to redeploy. Identifying the exception itself is very difficult. Maintenance is very difficult. A person who is entering into this particular microservice monolithic application, for him the code base is huge. Understanding the application will itself take so much of time. In case of microservice, it is not like that. One microservice is built in such a way that it can be managed by a people of what they say is the team size should be between 8 to 10. That is something like they can share a medium size pizza. That should be the size of your team for a microservice application. So these are few advantages of microservices. It is loosely coupled. One thing is fault tolerance is very easy. It is independent. If something goes wrong, only that you can identify the place of faulty microservice very easily. Maintenance is very easy. Then if a person coming into your application, they can easily understand how microservices work with. Okay, let me just go back. And here, each application that I have told you already. Yes. So how do we decompose our application into services? Okay. How do I know in what basis I need to decompose the application? There are different ways of doing it. For that only we have design patterns in case of microservices. You can decompose your application by functionality, by subdomains, by the way of database behavior. So based on your project, you can decompose your application. In this case, the application is decomposed based on the functionality. Okay. So what are the key concepts of microservices? This is very important. If you are working in a microservice architecture or an application, you need to consider all this. It is independent, self-contained. Self-contained means product will deal only with product, not with user, not with order, not with billing, not with any other component. This means what? Single responsibility principle. If you talk about Java, Java talks about single responsibility principle. That is solid design pattern principle. In that, yes, is single responsibility principle. It has to take care of one and one functionality and feature only. User microservice will deal with only user related stuff. That's what I said. The group which is going to take care of accommodation will take care of accommodation only, not about catering or not about any other thing. Independent development. Each service can be developed, tested, and deployed independently. Decentralized data management. Each service has its own database. Inter-service communication. The services can communicate through HTTP REST or using message brokers or using gRPC, remote procedure call. This is an open source framework for communication between microservices. Any doubt? Is this clear till this part?
Yes.
Yeah. Okay. Now, already we have discussed about the difference between monolithic and microservice architecture. Monolithic is tightly coupled, bundled as one single unit. Many applications, whatever we are seeing, they are incorporating both monolithic and microservice architecture. Now, slowly they are moving to microservice architecture. It is not that microservice is super good or super easy. It has got its own pros and its own cons also. It is tightly coupled in case of monolithic, microservice loosely coupled. Here, the presentation, the business logic, the integration, all put together is deployed as one single EAR file. In case of microservice, each functionality is a separate service. Monolithic, it is deployed as a single WAR file or EAR file, enterprise RQ file. In case of microservice, each service is deployed as one service instance. Okay. Now, this is the same thing, whatever I told. Now, we will just see the example. What is the difference between monolithic and microservice architecture? Monolithic, this is how it is. In case of microservice, each one is an independent service. And again, if the service is very simple and small, they can, what is that? They can use share their own database. Now, we need to understand when to use monolithic and when to use microservices. Use microservices when your application is small and simple. Monolithic when your application is small and simple. Going for microservices when the application is large and needs scalability. Why scalability? How it supports scalability? If I want to add new functionality without disturbing other things, I will create it as an independent microservice and add it to a part of my application. Okay, but in case of monolithic, if I'm adding a new functionality, again I need to redeploy the whole application. So that is the difference between monolithic and microservices, where to use it. Okay, here. What are the advantages of microservices? Whatever you have seen as key concepts, they are all advantages. They are modular in nature. Each service is modular. It concentrates on only single feature. That is, it consider single responsibility principle. Independent development and deployment. Each service can be developed and deployed independently. What service you need, that alone you can run also. Loosely coupled. Independently scalable. If I want to add new functionalities to an existing microservice without disturbing other microservices, I can do that. If I want to create a new microservice for my application without disturbing the other services, I can do that. Okay, it is faster because it's simple, small also. Improved fault isolation. If one microservice goes down, it is very easy to locate the place of failure. Technology diversity. This is one advantage which is being used by most of the companies. The service can be developed or updated in a new technology stack, meaning to say that it is not necessary that all the microservices should be developed using one single language. My dear guys, when I say microservices, whatever we have seen till now is generic, meaning to say the microservices, for whether it is developed using .NET or Node or Python or whatever it is, or in every place, whatever we have seen, it is generic only. It means when I am creating an e-commerce application using microservices architectural style, each microservice, whatever I'm using, can be developed using different technologies. As in, I can have 3 microservices developed using Spring Boot, 2 using .NET, 2 using Python, 2 using Node. What is the advantage here? They are not going to communicate using their own language. They are going to communicate using a common language, just like how we are communicating. For us, it is English. For them, it is through remote procedure call, that is REST API calls. What is the common content that it is going to send? Through JSON. Of course, I can do content negotiation also. If I want to say, I want it in XML format, I want in text format, I want in custom format, I can negotiate as a client. Fine. Now, this is the very, very important part that you need to understand in case of microservices. Fine. Now, let me just take it to that part. Now, fine. Guys, whatever I'm saying now is about the key components of microservices. This is what is being used in any industry if they are dealing with microservice architecture. Whatever I'm explaining here is curated from my experience, what I have got doing microservices training from different corporates. Okay. So first, let us understand it. Directly, I don't want to say, okay, use this. We will understand it using a pictorial representation. Assume I want to create a microservice application for, use microservice architecture for an e-commerce application. So what are the microservices I need to create? For product one, product, for user, for order, for billing, for cart. Likewise, I need to create microservices. So in the backend, we need to create microservices. Assume I'm creating a product microservice. Product, cart microservice, cart, then user, then maybe billing. These kind of microservices I have created. Now, how do the microservices communicate between each other? Yeah, between themselves. That is the biggest issue. First step is, first We have built a microservice. What do we need? We are all a part of the whole microservice ecosystem. Just a minute, please. We are all a part of the whole microservice ecosystem. It means I have to register myself to a particular place so that the other microservices can access me. So first thing is we will have a service registry. This is the service registry. All the microservices should register themselves to the service registry. Okay. So the first one is service registry. We have open source service registry that is provided by Netflix OSS. So it is Eureka Service Registry. Or you can use Console or Zookeeper. Okay. Next is, so this is okay, fine. What next? Suppose in my application, I have product. My product is connected to the database. And similarly, I have user. User also is connected to the database. If you are working in any application, if you are working in a Spring Boot kind of application, what you do, you have to provide the configuration details for connecting with the database, as in to which database you are connecting, what is the username, what is the URL, what is the password, and so on. And similarly, if you are performing certain security related stuff, you need to add all the details in properties file or application.yaml file. Now, what is the issue? Assume initially now I am working with MySQL database. Later on, or I am working with H2 database. Later on, after a period of time, they say that you need to change to MySQL database. What happens? Wherever you are having database, you will have to go to all the microservices. You have to go and modify the YAML file, redeploy the application again. Correct? Suppose in product, I have a YAML file or a properties file where I have provided the configuration details. I have to come here, modify the code, change the code and redeploy it. Here also change the code and redeploy it. So this is a biggest issue. So for that, they came up with something called as config server. So what is the purpose of this config server? First, let us understand. I have configuration details. Rather than having the configuration details added over here, what I will do is I will add it to a GitHub, a repository. It can be Git or anything. Now I have added the configuration details for user service to Git repository, for product service to Git repository. This means all my configurations are available in the Git repository. Next, what next? These two services has to take the configuration from Git repository. They will not communicate to the Git repository directly. Rather, we will have something called as a config server. This config server will have the location of the Git repository. I repeat, it is just going to have where exactly the Git repository is available, as in the URL. So you will just provide the URL of your Git repository in config server. Whichever microservice is connected with the database, they want the configuration details. So what they will do, they will connect to config server. Okay, they will connect to config server to get the link of the Git repository. It is something like a treasure hunt. Okay, assume the three people are playing. Me, you, me, and one other person. Now you are doing a treasure hunt. The other guy is having the original treasure is with the other guy. Now you are coming to me. I am not having the treasure. I am having the location of that particular person where exactly he is available. So you will get the location from me and you will go in search of him. Same way, these microservices will get the location of this Git repository from the config server. You might be wondering, why can't they communicate to the Git repository directly? Again, there is an issue. Initially, assume that I'm working with GitHub. Later on, I'm moving on to GitLab. Or later, I'm changing the repository name itself. If I'm changing the repository name itself, what will happen? Again, you have to come and check, modify it in user and product. This will be a bigger issue. But now Because config server is available, if you are doing any changes in Git repository, all the details you can provide it in config server only. You don't have to touch any of the microservice. This is the best part. So it is mandatory when you are working with the microservice application, or if you are building your application using microservice architecture, it is mandatory that you need to add this particular component. So config server is used for providing configuration details. This is the second one. Now the next one is gateway API. What is the meaning of gateway API? Gateway API is like a security. Whenever a request comes in, see, there is also actually something called as a load balancer. We will discuss about that. Before that, we need to understand what is a gateway API. The name itself says gateway, means it's like a entry, a pass. So please understand, whatever you are seeing here, one thing I forgot to tell, whatever you are seeing here is a microservice application. Can I see that application? Meaning to say that can I feel that? Will I have a UI? No. This is your complete microservice ecosystem. Now, external to this application, you will have the UI. The UI can be your React application. Okay, means there should be a front end, right? See, whatever we are talking is about the back end part. In the back end, I have one complete application. Usually, when you are developing an application, what you do, you have a front end, middleware, and the database. When you talk about microservice, it's only the back end part. What about the front end? How do I view it? So for that, you will have the front end, which can be in any form. As in, I can have my front end developed using React or Angular. Okay. So how do this fellow communicate with the backend microservice application with my application? They will make a REST API call. Okay. Is it only React or Angular? No, not at all. It can be a .NET application. It can be a mobile application, or it can be any other web application which wants to communicate. Say, for example. Okay. Now, very simple thing. You have Razorpay, right? So whenever you go to any website, automatically what it is doing, it is not having its own payment details. When you click pay, it is taking you to another application, which is through Razorpay. You are connecting to the backend bank server and you are just doing the payment. It is not a part of Zomato or Swiggy or any other application, which means there itself you two microservices or two applications are communicating between each other. So similarly, I can have some front end. Okay, there is some front end which is making a call to the backend. This fellow is not having that data. Again, he can make a REST API call. So all these, whatever you are seeing, are completely external to your application. You don't have to bother about them at all. You are bothering about the backend part. So we are discussing the details only about the backend part. Okay, now let me come to the gateway API. So here we have gateway API. Gateway API is like a security. Okay. Whenever a request comes from the external world into the microservice ecosystem, gateway API is responsible for routing, for logging the data, and also for server side load balancing. Okay. What is the meaning of routing? Assume I have got so many microservices. Each microservice will run in a particular port. This is in 8081. This is running in 82. This is in 83. This is in 8080. This gateway API will not expose the microservices directly. Now, from my application, from the front end application, they are not aware of the process or the port numbers in which these microservices are running. Now, the gateway API will expose them as some other port numbers. As in, if I give 9000 slash something slash user, gateway API will get it and route it to the appropriate service. If I'm getting it as 9,000 slash something slash cart, it will route it to the appropriate service. So gateway API is responsible for routing, for logging whenever data is coming in. And the last one is server side load balancing. What is the meaning of load balancing? Load balancing comes in two ways, actually two flavors. One is client side load balancing, the other one is server side load balancing. So if you are working in applications, monolithic applications, you would have heard about load balancing. What exactly it is? When I am deploying an application, when a client tries to communicate to an application, there will be a load balancer. And I have my application deployed not in one single server. It will be deployed in multiple servers, server 1, server 2, server 3. Assume each server has a load capacity of handling 1 lakh customers. Now, when a client tries to connect to this particular application, it cannot connect directly. It goes through a load balancer. The load balancer is responsible for picking the appropriate application. I am talking about a monolithic application, how it happens. So this load balancer is picking this S2. Assume S1 is completely full. It has reached the threshold level. It cannot handle any more clients. So automatically load balancer will pick the application which is deployed in S2. So load balance, this is called a server side load balancing. The load balancer decides which instance or which application to choose from which server. This is in case of monolithic application. Now coming to microservice. Microservice, only one instance is running. How it will know that I have to pick and choose what? I am having only one user, one cart, one, what is it I have written? Billing. Now, when I am creating microservice, I have to think and decide which microservice will get more users. Suppose meaning everybody wants to know, see the products, list of products, products by brand, products by category, blah, 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 and everything. So we will not run one instance, but rather we will run multiple instances of the same service. Multiple instances, it means just like an object. When you say a class, you are having one class, you can have multiple instances of a class. Same way, multiple instances of one service. So this one is running in, assume port number 8089. This is running in port number 8087. So I have got multiple instances of the same service running. When a request comes from an external world, the gateway API is responsible for picking and choosing the appropriate microservice. If somebody wants to connect to product, so based on certain patterns and criteria, it will pick one particular instance for connecting, just like this one. So this is called a server-side load balancing. Gateway API does that. So here we will use Spring Cloud Gateway API. Earlier, we were using Zool, but now Zool is in maintenance mode. Zool is given by Netflix OSs. It is in maintenance mode. So you need to know how to create gateway API. Okay, my dear guys, whatever components I'm telling you, you need to understand, create, develop application and have it as a portfolio. But when you go to certain places, say I told about State Street and Harman, what they said is, we will not use the open source Eureka service registry. Rather, we will develop our own in-house service registry for performing this operation. In case of Spring Cloud, of course, okay, we can use Spring Cloud Gateway API, or we will develop our own in-house gateway API. But what about the functionality? The functionality is going to be same. Okay, this is the third one. Next one. We were discussing about load balancing. So we need to know what is load balancing. Okay. In case of gateway API, we talked about client-side load balancing. Now let us discuss about, server-side load balancing. Now let us discuss about client-side load balancing. What is Client-side load balancing. See, I have got so many microservices. It is not that, yes? Yeah. Now I have got multiple microservices. It is not that only the front end or the external application is going to communicate to this microservice. There are scenarios where the user can communicate to product. Cart can communicate to product. Cart will go and check what are the products available and then add the items to the cart. So in these scenarios, cart becomes the client for product. User can communicate to product. User becomes the client for product. Billing. So assume I have a scenario like this. Cart is there, product is there, billing is there. Cart communicates to product. Now what happens? Whatever, this is the client, this is the a microservice which is going to give the data. Billing communicates to cart. As in, I have billing communicates to cart communicates to product. These are three different microservices. Now, cart becomes the client for product, billing becomes the client for cart. So in that case, we will be working with client-side load balancing. What is the meaning of client-side load balancing? Client has the authority to pick and choose which microservice instance it wants. Cart service can decide whether to choose 81 or 89 or 87. So this is called as client-side load balancing. This is also another important factor. We will be using ribbon, or you can work with Spring Cloud Load Balancer. Okay, fine. So this is about the next one. So this is all good to go. We have seen load balancer and everything. What is the important part? Fault tolerance. So that is, we will be using circuit breaker design pattern. Fault tolerance. What is the meaning of it? Here we are having multiple microservices. That is same thing. Cart billing connecting to cart connecting to product. Suppose say this particular product microservice is down. If this is down, you will not get any output for cart. Cart will not get any data. This means cart will throw the exception to billing. This means billing will throw the exception to the external application. They are all interconnected. So what is mandatory? I need to handle the fault tolerance. So for that, we will be using circuit breaker design pattern. That is the library that we will be using is Resilience 4J. So what is the meaning of circuit breaker design pattern? When the product microservice goes down, assume the number of requests coming to product service is going beyond a threshold. Automatically, that particular microservice goes down and it throws an exception. Okay, it's not available, it throws an exception. It enters into cart. Now, it is the responsibility of this particular microservice to handle the exception and throw user-defined error message. So we have, this is again important factor when you are building your microservice application. Okay. So we have seen fault tolerance. What next? Next is distributed tracing. What exactly is the meaning of it? Here I'm having multiple applications. I want to find the latency, how exactly my application is performing. I'm sending a request from the client side. It enters into the microservice application through the gateway API. I want to know how long it will take for the response to come back to the client. So to handle that, to know the flow, to trace the flow of your application. So how it is going from cart billing to cart to product, or from user to product, or user to wish list to product. What is the flow of my application? For that part, distributed tracing, we need to use Zipkin. Okay, so these are all the libraries that you need to know if you are working in a microservice application. These are mandatory parts that you have to use while developing your microservice application. Other than that, okay, 1 minute. Yes, any question? Now can you hear me? I heard that you guys are not able to hear me. Is it clear? Hello, can you hear me?
Yes.
Yeah. Okay, thank you. Thank you.
Are you going to show these components now in a real-time application, how they look?
As of now, we will do a basic example. Okay, we will do a basic example. We will create a microservice and we will do a basic example. See, each component is literally like kind of, it takes 2 hours to develop. Like you need to add it as a dependency and then you will be doing it. So I'm just telling, when you are developing it, you need to see, you create a microservice. You feel that you want to do fault tolerance. You will have to add the dependency, just like how you do try catch, handling the exception. The same thing you will be achieving with fault tolerance. So similarly, I want to create it as just as a gateway API. You don't have to add any code. It is not a microservice at all. It is just a person he's like a security. So programmatically, declaratively, I can show you the code, but you will not get an understanding. Yeah, just a second. Okay. So yes. So these are the key components: API gateway, single entry point for all the client requests. It's very clear, just like a security. Service registry, single point of contact. Everybody has to register, only they will be visible for other services. Configuration management, centralized storage for service configurations. Load balancer, distributes traffic among multiple instances at same microservice. This is client-side load balancing. Then circuit breaker, prevent service failures from cascading by stopping repeated fail calls. The microservice itself is already down, but still you are sending request again and again to that microservice, means it will be an issue. So you need to handle it. So for that, we will be using Resilience 4J. Logging and monitoring. So for tracking issues, like we will be using Zipkin, ELK stack, and Proximus. Fine. Now, there are few patterns. Let us not go into the patterns. Let us get started. We will do a simple microservice. First, for that, let me explain what are the things that you need to do. Suppose say I want to develop a microservice using Spring Boot. Okay. What are the steps that we need to do? First is you simply create you all know to create a Spring Starter project. So you will be creating it as a Spring Starter project. What is the dependency that you need to do? We have to register this one as a client. Actually, this is a client which has to register to Eureka Service Registry. Guys, please don't annotate the screen. Yeah. Spring Starter project. Okay, you don't have to worry at all. We will do it from the scratch. Even if you are new to Spring Boot, you will understand it. But if you have worked with Spring REST API, it is as simple as it is. You need to add the dependency as Eureka client. Okay. Then you add your controller. What exactly this microservice is going to do, whether it is going to deal with product or deal with user or deal with whatever you want, to add the details. Okay. Then after that, the important part is you need to provide certain configuration in application.yaml. That's all. Suppose if this microservice is connected to the database, you will be adding database configuration details in the YAML file. I cannot do that. Why? Because we have to create config server, which is a separate service. So everything will be separate and independent services. So this is for creating the microservice. When you run this, it will behave like a normal REST API. Now I have to register my microservice to Eureka Service Registry. So the next part is we need to create a service registry, which is Eureka Service Registry. And here, what do? You don't have to add anything extra. You need to explain that this is a server. So you will add one annotation, enable Eureka server. That's all. And add certain configuration details in application.yaml. That's enough. Once you do this, the server will be ready. What now? You need to run the server first. This is your Eureka registry. Run the registry first, then run the microservice. Here also you will be adding one annotation similar to this. Enable Eureka client, discovery client, meaning to say that I am a service, I should be visible for others. Please understand, it is not for registering. I am a service, I want everybody to use me. So we need to use at enable discovery client. After that, when you run this, then you run it. Automatically, this will go and register itself to the service registry. Okay. Now we will get started. If you guys are having Spring Toolsuite, nothing else is needed. It is enough. We will create a microservice. We will create a Eureka service registry. We will check whether the service is registered in Eureka dashboard. So we will have a Eureka dashboard. We'll check whether it is registered, and also we will test our first microservice. Okay. Yes. Now let us get started. Okay. So I'm in a brand new workspace. So let us get started. So you can do it in two ways. First, create the microservice and then create the service registry. Or first create the service registry and then create the microservice. So we will do the second part. First, let us create the service registry. Okay. First, go to File, New Spring Starter Project. Okay. Eureka-service-registry. Our project management tool is Maven. Packaging is jar. Java version should be 21. Because we are working with Spring Boot version 3.4, it expects Java version 21. Group ID, let us have it as say com.example only. If you are going in for a specific domain model, as in if I am working with an e-commerce application, it is about product. If I am working with Book My Show, it is about movie. If I am working with a restaurant app, it is about restaurants. So in that scenario, you give the name appropriate names. As of now, let us have it as com.example. And the package name also, let us have it as com.example. Nothing else to change. Remember, packaging should be jar. Java version is 21. Type is Maven. And what about the naming convention? Till Java project, what is that we were taught? Use only first letter capital. If you are using two words, the first letter of the second word should be capital. That's what we have learned, right? Even for Spring Boot also, that is what we have used. But starting with microservices, they prefer to use only hyphen. When I say they, this is a custom that developers in the community has made. So it is always better to go in for 3 words with hyphen in between. 3 words with hyphen in between. You can just specify what actually you are creating. Suppose say you are working with C. Let me just show you. Let me open the other screen. So you asked for the microservice, right? So this is the one that we have created. So we have a Eureka server, config grid server, then card service. Then we have included resilience 4J. Then we have got book view. One last thing which I forgot to tell you is, we discussed about all the microservices and everything, right? One thing is, one important part, which is the star for today is Kafka. What is Kafka? Kafka is used, it's an event streaming platform, real-time event streaming platform. Suppose say I have placed an order in a restaurant. I want to track the order. When I click track order, I will get to know the location where exactly this guy is available. So that real-time event streaming can be achieved with the help of Kafka. One other simple example I will tell you. So I assume this is a microservice application where I have got product, billing, order, all I have created. Now, the moment a user also is there. How the microservices communicate between each other? When this fellow is giving it, if order wants to get it, order has to call product to get the data. User has to call product to get the data. Correct? This is how it is. This is how it happens. But now, what I want is, once a user has placed an order, the information has to be stored in a server, which is called as Kafka server. This is message broker. It is something like WhatsApp. I want to communicate with you, but I cannot reach you immediately. What I will do, I'll come and add all the junk, whatever I want, I'll just come and add it in WhatsApp. When you open it, you will get it, correct? Similarly, once the order is once the user is placing an order, a message will be added to Kafka server. Okay. Now actually there will be some service called as notification service. What is the purpose of notification? You guys all keep notifications ready, right? If you add notifications in your phone, automatically you will get details about the offers in Amazon, offers in Swiggy, Zomato. You get it automatically on the top. So similarly, we will have a notification service that is created. How actually this notification service will get the data? It will be continuously listening, just like how we are listening to our messages. Immediately one bell rings, ting, automatically we are opening it, right? The same way, this notification service will see it continuously. Now it knows, okay, fine, the order has been placed. So some message has been written. It will consume that message and send it to the appropriate places, maybe to WhatsApp, maybe to email. Suppose say you are placing an order. Nowadays in all the websites it's available. The moment you place an order, automatically you will get an email. At the same time, you will get a WhatsApp message saying that your order has been placed successfully. Remember, notification service is not calling order. It will not call order. Automatically this happens. So that is achieved with the help of Kafka server. This is real-time event streaming platform. Okay, this is the big boss today because it has got so much of clarity. Many applications are using it, including Amazon, Uber, PayPal. Every other application is using this Kafka for event streaming. Okay, now coming back. So here you can see this. We also created something like order. When an order is placed, automatically I will send the date. The inventory has to be reduced. I am buying 10 items, 10 jackets. So in the backend database, the inventory has to be reduced. So inventory also will be listening. At the same time, there will be a notification service. That also what it will do. It will just go and check, okay, fine, I want to send an email. So we will be using in mail sender to send the mail to which person, which subject, what is the message, all that put together, we will send it. So this is how it works. Okay, now let me go back here to this one. So Eureka Service Registry, click next. Spring Boot version is 3.4.3. Just to search for Eureka. Select Eureka Server. Click next and click finish. Now the application is getting created. Let me open it. Open SRC main Java. Open the main class. Annotate the main class with at enable Eureka Server. At enable Eureka Server. This is the only annotation that we need. We don't need any other code. But together with this, of course, we need to add configuration details. So let me open SRC main resources. Already there is a file which is application.properties. My dear guys, in case of microservices, again, as I said, YML is more preferred than properties file because of the indentation part. You are not repeating the lines again and again. So it is very easy to just see the code. It is like picture perfect and clean. So people prefer to use YAML. But all by default, application.properties file will be created. When you are working with the microservice application, it is mandatory that you need to give a name for your application, for every application that you are creating. By default, the application name is given in application.properties. If you are adding it in YAML and if you are adding it in properties file, there will be a conflict. Why? Now only one microservice. When you are having multiple microservices, how do the microservices communicate between each other? Through names, whatever name you are giving. If you are having two names, it will consider only the name in the properties file. So delete it. Now let us create the YAML file. Or you can even delete application.properties itself. We don't need it. I deleted it. Select SRC main resources, right click new file. Right click new file. Let me give the file name as application.yml. Okay. First thing is we need to give an application name. So it is spring.application.name. Whatever you are seeing is the property. If you are using properties file, it will come with dot operator. Spring.application.name. But this is YAML, yet another markup language. It will come in multiple sentences. As in, it will be indented automatically. Let me press enter. See the indentation. Now let us give the name. Eureka registry -registry. Okay. And we need to specify in which port number it has to run. By default, every other application runs in the port number 8080. We don't want that. So let us give the port number server.port. Select it, enter. Okay. Now here, let me give the port number as 8761. We need to add few other configuration details that are relevant to Eureka. Whenever you are creating an application, you have to register yourself to Eureka Service Registry. So you have to provide that details. Eureka.client. Eureka.client.service URL. Press enter. Okay. The problem with YAML is it will be you have to be very careful with the indentation. Service URL in the next line, it is default -zone. I want the Eureka server to run in port number 8761. It is running locally. So it is HTTP. Give a space between the colon and the name. HTTP://localhost:8761. Okay. Together with that, this is the URL. This is the URL of your service registry. If any application wants to register, they have to give this particular configuration details in their YAML file. But now I am giving it over here also. What will happen? It will try to self-register. Okay. So for that, we need to add two properties. Eureka.client.fetch registry. So whether should I fetch registry? No, because I myself I'm a registry. So add the property as false. By default, it is true. Change it to false. Then one more property we need. Okay. Should I remember all this? You don't have to bother about it. You can just add all these directly from, you can go to spring.io. Let me just show you. Spring.io, Eureka Server. Eureka Server. Application.yaml. Oh, now directly it is coming from cloud one. This one. Getting started. Service registration and discovery. Scroll down. Now, register. Okay. Fetch registry we have given. You need to add register with Eureka false. So these are the properties that we need to use. It is enough that you just copy paste it and then you can run it. Here you are having an option to copy also. Okay, service registration and discovery. If at all you guys are trying it together with me, I am sharing the link. Okay. Now let me just go back. This one, right? Yeah, fetch registry. Next one is register. Should I register with Eureka? No, because I myself, I'm a server actually. Register with Eureka. Please be very careful with the indentation. If there is a tab space, it will not work. Delete it, space, 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 space. And the indentation should be proper. And I need to give value for this. This also by default, it is true. Now let me give it as false. That's it. Save. Okay. I'm also sharing this. You guys can copy it and try it out. One more thing, please remember the indentation matters. Once you have completed it, what you need to do is you have to run it. Select your application, right click, run as Spring Boot app. Let me maximize the console. Here, see the name that we have given in YAML file, the name of our application, Eureka Registry. Let me pull the cursor to the right hand side. You can see that the application has started in port number 8761. Okay. So let us check whether it is there. So what will I see? This is a registry. So it means it will have a dashboard. It will show the microservices that are registered to this particular registry. Let me open it. Here, localhost : 8761. Enter. This is how you will get. This is your Eureka dashboard. And this is the place where it will show what are all microservices that are registered with Eureka Service Registry. As of now, we have not created any microservice, so we are not seeing anything. Okay. I hope it is clear. Anybody tried and got it? Did anybody try? So if that is the case, shall I proceed?
Yeah, you can proceed.
Okay. So next, what next? The next step is like we need to create the microservice. Yeah. I'll minimize this console. This should be up and running. Now we need to create the next microservice. Oh, sorry, first microservice. File, new Spring Starter project. Okay. Let us assume that we are creating a microservice for a book application or a product application. Let us let us have it as products. Okay. So product app hyphen catalog hyphen service. So this is a microservice which is going to return me a list of products. Guys, as of now, we don't have anything. We will return a static set of values. Again, here also type is Maven, packaging is Jar, Java version is 21, language is Java. Let me have the group ID as com.product app. And let me have the package name also as com.product app. Technically, you can have the group ID as 3 words, com.productapp.dast. This is the place where you will add the jar file. Your jar file will be created. Okay, click next. Now, what is needed? This is not a server. This is a client. So we need discovery client. Can you see? Eureka discovery client. Select it. This is a REST API. So it is mandatory that we should add one more dependency, which is web. Select web. Scroll down. Guys, be very careful. Select Spring Web, not reactive web, Spring Web. Click next and click finish. Only two dependencies. See, remember, this is actually your proper microservice. If you are working with a database, you need to add database specific configuration. That is the data source, MySQL driver. If you are using product, you need to add Lombok. If you are adding security for your microservice, you need to add security specific dependency. So every microservice that you are creating will have that many, so many dependencies. As of now, we are creating it as a simple microservice. Click finish.
Madam, can we create this project using Spring Initializer, right?
Yes. Oh, if you are not
Yeah.
using Spring Tool Suite, what you can do is you can go here. Yeah. Start.spring.io. Sorry. Start.spring.io. Spring Initializer. Same way. Just like how you create a Spring Boot application, you can create it. Select Maven, select Java, Spring Boot version, then group ID, all that jar file. Then go here and add the dependencies. Click on add dependencies. The dependencies, whatever we need. Web, it is added. Then next is what? Like add dependencies. Spring, sorry, discovery client. Eureka discovery client selected. Now it is added. After that, click generate. It will be downloaded as a jar file. It will be downloaded as a zip file. You need to extract it and open it in IntelliJ. You are using IntelliJ?
Yes.
So you click generate, just like how you develop any Spring Starter application using IntelliJ. Click generate. It will be downloaded as a zip file. Open in IntelliJ, extract it using Maven. Then automatically you can work with that. My IntelliJ
Okay.
is expired, so I am not using it. Okay.
Yeah. Thank
So now here I'm having product app catalog service. Everything. See, here only the ID differs. Rest of the things are all same. So, okay. Now here, first step, open the main class. Annotate the main class with at rest controller. Sorry, at enable discovery client. Control space, discovery client. Then let us create the controller class. Right click, new class. This should be in controllers package. Please follow the naming conventions. So let me have it as product controller and click finish. This class should be annotated with at rest controller because this is a REST API. Now let us create one simple method which is our REST endpoint or a REST API. Public list of string show products and return arrays.asList. Let me add the products as mobile, comma, speaker, comma, television. Okay. And this should be annotated with at get mapping. If you are really working with the proper application connected to the database, you will connect to the service layer, from there to the repository, get the data from the database. So let me have the URL as /show. Let us also add one more method, a simple method as usual, which is my favorite, /greet. The return type is string. Greet. And let me have it as have a great day. Yeah, that's all. Import list. So these are the two methods that I'm having in my product controller. What next? Once my controller is ready, we need to add the configuration details. Again, here also, as I told you, in application.properties, it will have its own name. If you are okay with this name, leave it. Don't give a name in application.yaml. Or you remove this and give a different name. So select src main resources, right click, new file. Let me give the file name as application.yaml. Okay. I don't want this name. I'll give a different name there. In YAML, first is spring.application.name. Every other microservice will have this. So product hyphen catalog. Because,
Madam,
yeah,
sorry to interrupt. Is it compulsory to create a application.yml file?
it is not mandatory. You can work with properties file also.
Yeah, that's what. Already our application.property file is there, no? So
Yeah,
again,
already application.properties file is there. See, what happens is it becomes verbose. Every time you're writing, suppose I want to give the username and password for database, means spring.datasource.username, spring.datasource.password, spring.datasource.url. It means you are repeating it again and again.
yeah,
So to avoid that, they are using YAML file. So it's your choice, not an issue at all.
sure, yeah.
Next is port number, server.port. You can give any port number you want.
Can we keep both the files?
Yeah, of course, you can keep both the files. So in this case, I'm having both the files. Which will be given highest priority? Okay, I'll tell you. In application.properties, I'm giving a name. Let me give control set. Now I have given the name as product app catalog service. In application.yaml also, I'm having this. Which will have the highest priority? Always application.properties. It will register the application name only as product app catalog service. Okay, why? That is why if you decide to have the application name and if you want to have this properties file, keep it. In application.yaml, don't override it. It is not of any use. Because when two microservices are trying to communicate to each other, with what name they will be recognizing, they will be looking for this particular name. If you have given the name as product catalog, it will not work because that name is that microservice itself is not visible.
Okay.
So this is server.port. Port is, let me give it as 8081. And what next? Same thing, whatever you have added in the previous application, client URL and all that. So let me just go to the service registry. We don't have time, so I'll just copy from there. You only till this part. I have to register myself to the service registry. So this is the one that you need to add. Again, this you can add it directly in application.properties also. Here, if you just type eureka.client dot service URL, automatically you will get it. Dot default zone. Dot default zone is equal to localhost : 8761. So here I have, see, I copy pasted. It is giving tab space. Be very careful with the indentation. Default zone. In default zone, we should not hard code it. Rather, you give your registry name. So our registry name is Eureka-registry, all caps. That's what I have given. So I can just give it in this way. Okay. Now let us run this application. So I have just created one simple controller. Let's see, now here, sorry. One simple controller, which is going to return a list of products and one greet message. Okay. Select your main class. So I am having both the names. Please see here. I'm having names in both the files, in YAML file and properties file. Let us see which is having the highest priority. Select your application, right click, run a Spring Boot app. Let me maximize the console. See, now both the services should be running. One is Eureka Service Registry, the other one is Catalog Service. And see the name that is shown over here. In the YAML file, I gave it as product-catalog, but the name of the file that is getting registered is that is getting registered is product app hyphen catalog hyphen service. Whatever name that is there in application.properties. Why I am insisting on this means there are scenarios where we have got an error because we had both the names. We are calling it using the name that we have given in application.yaml. It will not even recognize that. So, okay, as of now, let us have it like this. Then not an issue at all. This application should be up and running in port number 8081 and it has registered itself to Eureka Service Registry. How to check it? Let me just go there. Sorry, in Eureka Registry. Let me scroll down to the bottom. You can see that registered instance product app catalog service. In port number, the status is up. See, every time I need to send heartbeats to the registry saying that, see, I am available, I am available. Only then it will update it again and again, the registry. Okay. Now let us check it out. First, you go to the dashboard. Click refresh. This time you should see your application registered here. Our microservice is registered to Eureka Service Registry. How to test it? Click. So it is up and running. Click on this link. Now we are having actuator. Guys, actually actuator is one important thing which will provide about the health and metrics of your application. So let us not talk about that now. Remove this. What is the URL we are having? Localhost 8081/greet. We are having only greet, enter. Here I have got the output. Have a great day. Means I have created a simple microservice. Technically, this is a microservice which will connect to the database, return the list of products. Now we are testing it. Usually, one microservice will call this using this particular URL. This has to return the data. Show, I think show, it is show or show products. Let me minimize this. It should be in product controller. Show, simply show I have given. Show, enter. So it is giving the list. Okay, you can test it using Postman also. Not necessary that you need to test it. Remember, in the service registry, with whatever name you have given, those names only will be registered. If any other microservice wants to call this, they have to call only with the name. Okay, how do they communicate? As I told you, they can communicate using REST or one thing also, again, I forgot. There is something called as Fiend client, which is called as a declarative client. Now we have created this microservice. Any doubt till this part?
No, good.
Okay. So remember when you are here, I'll just go here. So what we have done in this is we have created the service registry, Eureka registry. Then after that, we have created our microservice, the first microservice, which is product microservice. This product microservice, we have registered it to Eureka Service Registry. And we have tested it. It is working perfectly fine. Assume I'm creating another service, which is cart service. I want to get the list of products by brand. I want to get one product by ID. All that if I want to do, this cart service has to communicate to product service. How does it communicate? For communicating, we will be using an inbuilt class called as REST template. Just like how you are testing it in the browser or using Postman, here also we will be using REST template. Using an object of REST template, we will paste the complete URL. Instead of localhost :8081, you will give the application name, microservice name, product app -catalog -service. Like that, you will be giving it. That becomes still more verbose. Every other method, you will have to write it. So instead of that, we have something called as declarative client. This declarative client is called as Fiend. If you are using Fiend as your declarative client, you don't have to write any code at all. You are just going to create the abstract version of it. This Fiend in the runtime will create or generate the code for you and communicate from cart service to product service. So what is that is being used in the industry? Fiend client, which is called as the declarative client. This helps to avoid verbose coding that you will write it again and again to call a microservice. Let me just show you one simple example. Here, see, this is my first microservice. If you notice, I have got application.yaml. I have added few other things also. Like I am connecting to config server and all blah blah stuffs. That and all you leave it. Now this is my application. This service wants to communicate to the other one. Let me open it. See in the service implementation. See, how am I calling it? Using REST template. Every time I need to call using the URL, book service hyphen book API. You need to call it again and again, the URL. You need to paste the URL. Every other method you have to do it, which is a biggest problem. To avoid that, we will be using declarative client. So what is the proper way of doing it? Obviously, declarative client. Okay. Any questions in that? So I hope actually, yes, somebody has asked questions. Yeah. Yes. Okay, fine. Now, the next thing what I want to know is like, how many of you are interested to learn microservices? Are you guys looking forward to learn microservices? If you can answer in the chat window, it will be really good. See guys, actually, yeah. Actually, first thing is like, let me just tell you certain things. I'm starting with the microservices batch, starting from tomorrow, weekend sessions like evening 3 to 6, or it can be 4 to 7, something like that. Like we are starting the batch and it is a 4-week session. Let me tell you what are the topics that we will be covering. Let me share you the topics that I will be covering. Please bear with me for a few more minutes. So whatever we have seen is just an introduction and the base. So going for then from this, let me just show you. So one other important point also, here we have learned how to use or how to work with microservices and register them to Eureka Service Registry. That is what there is one other extra component, which was an interesting thing that I did for a startup. I went for a training in a startup where they said that you teach microservices, but don't use Eureka Service Registry. Every other microservice should be deployed only in Docker. The microservice should communicate only within the Docker environment. So that also is a part which you need to know, because it's not that every time people will be using Eureka Service Registry or any other registry. Okay, this is the course outline. So this is a 4-week session. I just want to talk about the course outline first and what are the offerings that I have got. So this is week 1, where means tomorrow we are starting, where directly I didn't want to jump into microservices. I want to give a heads up on spring-data-jpa, as in we need to understand so many other intricate topics of data-jpa. Many of you would have worked with data-jpa, I understand, or few of you would have not touched it at all. I want to give an introduction about what is entity, repository, how to perform CRUD operations with the database, what are derived queries, named queries, native query, how to create and work with custom queries. So all these. Then other than that, we will do a proper project, as in it's not using one single class, but with the other associations. As in I'm having one product in many categories, one category having many product. So one to one, one to many to many, all put together, we will be learning to perform CRUD operations. It means our product catalog service that has to be a part of our application will be ready. So you will be also learning about pagination and sorting for sorting, and how to create custom queries for searching. All that we will be learning. We'll be also learning about transaction management. This is about the week 1. Now the backend for one particular service is ready. Next, we'll move on to the second week. In the second week, whatever we have seen till now, we will be doing it. Together with that, when now we did a simple microservice, but now we will be working in terms of project. No basic one. Directly we will jump into the project. The microservice that we will be creating is this one. We will be converting our Spring application into a microservice. Okay, so this is the microservice part. We will be learning about the different design patterns, because even in interviews, they ask about the different design patterns and which design pattern to be implemented for what. So the design patterns and how to communicate between microservices using Fiend client, what are actuators, what is the purpose of profiles, all that we will be learning. Then we will move on to the next part using Spring Cloud Gateway API and also about the config server. What is the purpose of config server? Whatever I have added here in the YAML file or the properties file, I will remove everything, throw away everything. I will add it in the properties file, application.yaml. See, just like how I have shown you here. So this is how we do in the resources in application. Not here, this one, JPA. So here, see this, connect to the config server. So what this config server will have? The config server will have only the details about the, that is the location, literally the location of the GitHub. Location of the, so this is the place where I'm having all the YAML files. Suppose if you are working with dev environment, you are working in a testing environment, you are working in a production environment. Based on that, you need to give your configuration file name. So data.jpa will, catalog will connect to config server. Config server will connect to, will give the location of your GitHub URL. This is how we will do. Okay. So then we will learn about fault tolerance using Resilience 4J and how to do distributed tracing. Please understand, when I say Resilience 4J, just like how you write a try catch, this Resilience 4J is going to capture the exception and give a user-friendly error message to the client who is calling this particular microservice. That is the thing. So centralized configuration, Resilience 4J, adding fault tolerance, distributed tracing with Zipkin, monitoring and observability. That is with Zipkin. Then this is the big boss. This is very, very important and one of my favorite. Last week we had a session on Kafka also. So just to get an introduction about Kafka, what is Kafka, where exactly Kafka is used, how do you communicate, how do you install Kafka? Installation of Kafka itself took years for me, like days for me. Earlier, I'm telling in 2020. But now if you're in Docker, using Docker, you can install Kafka. Then how to communicate between microservices using Kafka. Then Dockerizing microservices. That is here, no registry, nothing. All the microservices will be deployed in Docker and they have to come containerized in Docker and they will be communicating between each other. So this is how we will be doing our application. So any questions in this? Yes, any questions? Yeah, okay. And now, what are the key highlights? I'll tell you. This is the microservice training for, this is completely hands-on training only. We will be doing it for 4 hours every week. 8 hours, literally 8 hours every week, 3 to 4 hours it will take. Live coding, hands-on, we will be building a real microservice project. And remember, whatever topics I'm giving, even any other place, actually it is not available because I have curated from the corporates wherever I have taken the training. Okay. So this is about it. And what are the things that, what are the advantages that you will get also, that also let me just tell you. So once you have completed this, so together with this, you will also have, I will be giving you a microservice interview Q&A guide, which is having 50 questions starting from basic to advanced, basic, intermediate and advanced. What are the best practices that you can use for microservice? You will have a solid microservice application built all by yourself that you can showcase in your portfolio. You will have a microservice. I have a course which I'm just creating now. That course access you will have for 6 months. And whatever my training that you're attending together with me, That recording access also is available with you for lifetime. Like any point of time, you can come back and just check it. You might be wondering, will it be useful for lifetime? Java, whatever I have done years before is being used now. Same way, microservices also, whatever I have done earlier is being used now. Only here and there, few parts may change. Just like as I told earlier, we used Histrix for circuit breaker, Zool for gateway API. They are all outdated. Okay. Yes, actually, Kubernetes, many people were asking, Kubernetes and deployment in cloud. So because many were asking, I thought I will do the deployment in cloud alone. If time permits, I will give an introduction to Kubernetes because I also want to say how actually microservices will be deployed in Kubernetes. If time permits, we will do. So my dear guys, actually it is 4 weeks, 25 hours I told, but it will not be like that. We cannot finish any topic in 3 hours. We need solid 4 hours. So every week it is 8 hours, 8 into 4, literally it will come to 30 to 32 hours, and it will be a full-fledged hands-on training. Trust me, this will help you to upskill yourself for microservices. Like if you're moving forward in your career, like if you want to upskill yourself for microservices, this will be the right time and you can just take it. Okay, so do you want to know the pricing? Okay, guys, like I hope everybody, whoever is here is like in the whoever is here is in this community, like they are all, you are all in my community, right? Like in the group, WhatsApp group. Just give me a sec. Let me share it now. Okay, guys, I'm sharing the price. The original price is 16K. The early bird offer is 12,499 including GST. Whoever is willing, please DM me, or you can just connect. You can just connect with me in this number. This is my number. You can connect with me in this number. We can discuss about it. So this time I was supposed to start it last week, but I couldn't. This time we are starting it tomorrow. Please don't miss this. Whatever topics I am dealing, they are all the hot selling cakes of any corporate that you are working with. And again, this curated structured learning plan, nowhere I can just damn sure tell you nowhere you can get it. So that is how this is prepared. Any questions on this? Yeah. Now then, shall we wind up? Whoever is having any questions or any queries, please connect with me in this number. So this is the price. If you are interested to join this microservice training, please again connect with me. I will share the other details. I hope the session was useful. Can you please share the feedback about the session? It will be great if you can share the feedback about the session also. Guys, every week I am conducting sessions, webinars, free webinars on certain topics. If you are interested, please do join that. Yeah. Thank you so much for the time. So this is my number. You can connect with me if you are interested to join the microservices training that we will be starting tomorrow. So thanks everyone.
Thank you. Yeah, thank you, Sri.